Imagine witnessing a cosmic spectacle, so vast and powerful, it feels like a volcanically growing monster, erupting in the farthest reaches of our Milky Way galaxy. That's exactly the extraordinary event NASA's James Webb Space Telescope has recently captured, revealing a gigantic stellar jet stretching an astonishing 8 light-years across, about twice the distance between our Sun and its nearest stellar neighbors, the Alpha Centauri system. But here's where it gets controversial. This incredible outflow challenges our prior understanding of how massive young stars interact with their surroundings. Located approximately 15,000 light-years away in the galaxy's outskirts, this stellar jet emerges from a young protostar that weighs as much as 10 times our Sun. Such an enormous object is carving its presence boldly into space, shooting plasma at phenomenal speeds through a nearby nebula known as Sharpless 2284, or SH2284 for short. The jet's shape and energy output are so striking that NASA likened it to a double-bladed lightsaber, similar to the iconic weapon wielded by Darth Maul in the Star Wars saga, an imagery that perfectly captures the ferocity and elegance of this celestial phenomenon. The region hosting this stellar jet is a protocluster, a group of galaxies in the early stages of formation situated on the very edge of the Milky Way, nearly twice as far from the galactic core as our own solar system. Within this bustling nursery, hundreds of stars are still in the process of forming, but this particular jet's immense scale and power stand apart. Previous observations of protostellar jets have mostly come from smaller, low-mass stars, so encountering one of this magnitude opens new doors in astrophysics research. And here's the part most people miss. The discovery fundamentally shifts our perspective on how star size influences jet activity. The findings, led by astronomer Yu Cheng of the National Astronomical Observatory of Japan, suggest that the larger the young star, the more dramatic and energetic its stellar jet becomes. Before this observation, we had no idea that such a massive star with a superjet existed in this part of the galaxy. Cheng remarked, "Seeing molecular hydrogen blasting out in such spectacular fashion from a high-mass star like this is extremely rare, and tells us much about the early life of stars. Moreover, this discovery hints at something even more intriguing. If one massive star can produce such a colossal jet, there could be others nearby." Supporting this idea, scientists using the Atacama Large Millimeter Array in Chile have identified another dense stellar core in the same protocluster, potentially an earlier stage massive star, still building up mass, though not yet erupting so violently. All these findings were recently accepted for publication in the Astrophysical Journal, providing a fascinating glimpse into the violent and dynamic processes that give birth to stars, and by extension, the galaxies they inhabit. So what exactly is the James Webb Space Telescope, the instrument behind this remarkable discovery? Launched on Christmas Day 2021 from French Guiana aboard an Ariane 5 rocket, Webb began its mission in July 2022. Unlike Hubble, which orbits Earth, Webb follows a path around the Sun. Its massive gold-coated mirror measures over 21 feet in diameter, making it the largest, most powerful, and most complex space telescope ever built. Equipped with advanced infrared instruments, Webb can peer through cosmic dust clouds and reveal the hidden universe with unprecedented clarity. Although initially designed for a 10-year mission, engineers believe Webb's fuel reserves will allow it to keep exploring for more than 2 decades. This discovery not only underscores Webb's extraordinary capabilities, but also ignites new debates and questions. Could these massive jets influence the formation of entire star clusters and galaxies? Are we only scratching the surface in understanding how massive stars shape their cosmic neighborhoods? And more provocatively, could phenomena like these reshape our theories about star formation and the life cycle of galaxies? We'd love to hear your thoughts. Do you think this finding will soon rewrite astrophysics textbooks, or is it an exciting outlier? Join the discussion and share your views on how this volcanically growing monster is changing our understanding of the universe.